Time for another week of work and another stream. My last two streams I was goofing around with making some animation tooling, which was a lot of fun, and there's stuff I can continue with on that front. But I feel like it's important for me to turn my focus toward my Forge 3D modeling library to continue making progress on that, so that I don't forget what I've done so far, and I can keep adding the features I know I'll need with it, make it more robust, because I have a few design projects I want to do again soon. Finish the dumbbells one, although I still have, even that could arguably improve, but there's improvements to be made, and I figured today would be a good time to start putting my head back toward that. Because if I do little side projects too often, I can just completely derail myself and lose track of what's really the more important set of things to do, which is related to the libraries that I'm using to actually make designs. So that'll be today. Hopefully I can get some things kind of sorted out, but don't have much of an exact plan. I just kind of got to figure out what ends up working. So without further ado, I shall have a look here. So one thing I want to do first is maybe I can show this. Oops. So here, I'm not going to show the animations, but I think there's a file in here that is a good example of here. Okay. This was a thing I was working on with some animation stuff. It's a path trace of the letter B. It happens to be flipped the wrong way, so it looks like a D. But the thing that is important to recognize is, well, it's a little hard to see it, but this is ideally this is a sketch that is a polygon, the outer line here, and a separate set of points, which is an inner polygon here, which would be a hole on the path. But you can see it a little better maybe at the bottom here. The way that the polygon function works so far is it expects a list of points, which is assumed to be all part of a continuous polygon, and so you cannot properly show holes or disparate paths, or disparate loops or wires or whatever, as if they were the same path. The reason I would want to do that is for a sort of abstraction like a 2D sketch, where it can have, things like this, where it can have shapes inside of other shapes, or a shape here and like two disparate shapes, but you might want to do let's say an extrusion over both of them or something like that. So the ability to treat multiple lists of points as part of the same path is something that I think is kind of important. So this is just an example of how that doesn't currently work. So what I think I would like to do is use OpenSCAD, I should say, as a bit of a guide for how I might also implement this idea. So if I go to the cheat sheet here, I can click on, there's a polygon function for 2D stuff, which I can find right here. So the way this works is, let's see here, creates a multiple-sided shape from a list of x and y coordinates. It can also produce concave and convex edges, which makes sense. And it can also place holes within that shape. That is the element of interest for me here. So the way it's done in OpenSCAD is there's two arities for the function here. So what that means is, well, so it pretty clearly, if you just give it a list of points, it assumes that all of those points are on a single path. But if you give it a list of points and then you provide paths, which I do believe is sets of indices to point at the points that the paths are made of. Anyway, if you pass points and paths, you can create multi-path polygons. And that's what I need to be able to do with my polygon function. I kind of have cheated that earlier, or well, cheated it. What you can also do is you can union two paths together and then extrude that, and it's kind of the same idea, but I want it to be implemented a little differently. So, okay. Well, let's see an example with holes here so I understand it properly here. Okay, yeah, so the paths here, so the total number of points in this example is 6 because there's the outer triangle and inner triangle totaling 6 points, makes sense. The paths here is just the indices to which points. So what I don't know if I want to do it that way. It might make sense instead to make, I mean, the first thought that comes to my mind here is, let's have a look at the polygon function. Let's start there. This is not what I need here. Let's go to the polygon here. This is just a helper, which is fine as it is. FREP, this does need to be fixed up because of, well, the way I am assuming triangles are added together for this whole functional rep probably needs a lot of rework, but I will work on that probably at another point because that's a bit of a harder problem. I don't currently have the solution in mind for that, so I'll just move on for now. What I kind of want to do is convert this to, well, let's see. Oops. Okay. If I go polygon, instead of points, I would prefer to do paths. Let's start with that. Actually, let's do path. Does this work? I wonder. Path and paths. Let's see if that works the way I want it to. We'll just do this path list path paths. Okay. Also, I should load file source forge proto. There we go. Then pop into the namespace. Not this one, that's triangulation. Oh no, that's the right one, never mind. Okay, we're good. Okay, oops. Okay, polygon 2. Polygon 2, I want to see how this destructures. So either I could pass it a path, which is a list of points. So let's do 0, 0, 0, 100, 0, 0, uh, 0, 100, 0, say. So that returns, yeah, okay, that's not what I need, right? So what it's done, oh, no, that's because I've actually called this incorrectly, right? It should instead be like this. If I put another thing in, oops, come on. That was a fat finger typo. Okay, this is correct now. So there's only one path in this list. It's confusing because I'm just generating, like you have to nest it a bunch. I also don't know if that's a smart thing to do because maybe it would make more sense to do this. And paths. Does that make sense? So if I run polygon 2 with the first approach here, that's just one path. But if I do this, this can now be another path. There's a list of paths there. This is admittedly a little hard for me to make a decision about how to do this. I think okay, so the way polygon, a single thing works right now right? If I do regular polygon points, that, with it, let's give it a radius of 5 and 12 sides, that is a list of points. And I can run polygon on this directly. And that produces a function for each line in that set, and everything makes sense to me. I need if I run polygon 2 on end paths, right, but I only give it regular polygon points, radius 5, 12 points, or 12 sides. It's the same idea, but it's nested, so I could points 6, 20. Okay, this is what I do need, right? There's this list of points is a path of some kind. This list of points is a path of some kind. But both of those lists of points are in a single polygon. So that's important to kind of have them grouped like this. So that does make sense to me. Now it's just a matter of building out the function calls to properly reflect the fact that they are grouped together. So let's just see what I can think of here. History should be easy. History, just like I'm doing, although I do think I should I think I should rethink the history call here, because it builds up very, very quickly and makes the map quite large. So it might make more sense to change history to just literally be the last call, or like the current call like this. Tilde. Like that, right? So that should, let's see how that looks. So let's run that now like this, right? So now the history of it is, if I pull the history from that file file from that object, def a polygon 2, that's a bad thing to do. So if I just do history from this, and then I eval that, it should give me back the object effectively. Eval, how does this work again? *1? No. Huh, that didn't work the way I thought it would. Map eval over this, maybe? Something wrong with that? Okay, that's fine. Let's see. Why would that be a problem? Oh, wait. Do I have to do... How does this work? Is it like that? Oh, wrong. I don't remember if this will actually do what I want. That looks correct. Let's see if this will work now. Why is that wrong? Wrong number of arguments, 11, are passed to Clojure lang persistent vector. Yeah. I don't know why that's wrong. I have to... yeah, I don't know. Why? Okay, well, let's just... If I do this... Okay, but if I do it with this, does that fix the issue? It kind of does. This seems inconvenient to me. Let's do this though. Let's try to understand what's going on here. Def A has a history, right? So if I do history of A, I get this thing. If I eval history of A, if I now do history of this, and then I eval it, it should do this. It should give me the same thing again. And it does. Okay. So it's related to regular polygon points returning a list instead. So I think I can do wait a second. Map v vec. I don't know if this is smart or if it'll even work, but let's try it. So if I go like that and I now do, let's have a look back at this. Okay, that should work. Yes. Okay. Eval history of A. Okay. Seems to be working. So we give polygon 2, which will become polygon, I hope, and paths, so it can work on a single set of points or on multiple. It'll just run basically everything else normally. So this history will be wrong for now. Actually, no, let me just do this and fix history later. Let's do frep. So now here's the thing, I have to change out these functions to also accept and paths, basically. So what this means is here for frep polygon, I do need to build a better, let's have a quick peek if I can do see if there's sign distance function examples. Inigo always has fantastic resources on sign distance functions, and it's just a fantastic 2D distance functions page. This is just a great look at how it's implemented on the GPU through shader languages, but you can use that because it's got just kind of mathematical logic there, and you can use it nicely for implementing your own stuff. So what I'm wondering is if there exists a generic polygon kind of, okay, polygon exact. This theoretically would be what I use instead of my little union approach here to build a sign distance function of a 2D polygon. So does that make sense? I think it kind of does. Okay, so let me write a note here and just my frep polygon uses this did break for me in some cases, so I am going to test an alternate implementation. I will port this code. Right, so if I polygon exact, maybe I'll take this oops. Wait, can I just make a link to a section directly? Inspect element. Well, okay. Whatever. Oops. That's good enough. I know where I'm looking. Okay, so that, I'm lazy for now. Maybe I'll approach it in a little bit. But now, oh, I also do need to, every polygon function must work on and paths, not just a single list of points. This is to allow multi-shape paths. Example, a circle with a hole. As well, any polygon union should effectively produce a single polygon should effectively produce the same polygon that would result from providing each path into one polygon call. That is, let's see, union polygon points A with polygon points B. Okay, so you run that union is equal to polygon points A points B, which means I could what's the right thing to do here? Right, I could implement polygon this way, basically as a reduce over and paths with the union function. Maybe that would do the trick, but it's a little confusing. So I'm not gonna worry too much about it. I'm gonna go with what pops into my head. So I have to figure it out. First, though, I'm going to save this so I have a change tracking there. And still, regrettably, haven't managed to finish the animations for this, but should hopefully be soon. But I will be right back. Okay. Let's see what I can do. Vertices should be pretty easy. It should just be map cat vec over paths. Is that true? I don't think that's true, actually. No, it should. So since the vertices, this is basically just meant to be just a list of all the vertices that ever get used in a construction of some kind. So if you lose every bit of data except the vertices part, you'll have effectively a point cloud. And you could partially reconstruct data and things like that. But it's not meant to hold relations or anything like that. So you can just basically tack points onto it. So I just have to do that in a non-silly way. So all that is just concat paths, actually. Is there a concat v? I always forget. Concat or concat new? What is concat new? I don't remember what that is. Oh, right. Concat new is a it's like if I have a 1, a 2, a 3, a 4. Concat new is just 5, 6. If I do 3, 4, 5, 6, I think 1, 2, 3, 4, 5, 6. Yeah, it just makes sure that there's no duplicates, which I believe I use in the union function, but I don't actually need that theoretically for, although might be good to do that. Just remove duplicates, because it doesn't strictly speaking matter. Let's try it. Let's see what this looks like. Concat new paths. Let's try it on the REPL here. Concat new. Let's do a path. Yeah, 0. Let's do 0, 0, 0. Yeah, 100, 0, 0, 0, 100, 0. Let's do that. Is one path, and then another path is 0, 0, 0. 110, 0. 10, 100, 0. A weird triangle that would, yeah, valid. Okay, so concat new creates 1, 2, 3, 4, 5, a list with 5 long, eliminating the duplicate 0 there, which should be fine, and it does provide it as a vector already, which is fine. I do wonder if I concat, just a regular concat here, the difference, it does not return it as a vector, it returns it as a list. So that's maybe an issue with my implementation because it's not consistent, but I'll leave this like that for now. I'll leave it that way. I think that's okay. So that's vertices. It's nice and simple. Let's tackle the curves idea now. So this one I have to do on a per path basis. So So what that means is let's see here. Let's make a new function. We'll call it what should I call it? Oh boy. Oop. Let's see, define I want to call it VREP lines, but now I'm just wondering if there's a smarter way to run the to set this up so that I don't have to make a new function. But I'm not so sure about that. Okay, we'll just do it. We'll just do something like this. We'll just do VREP lines. We'll just do it that way for now. It's better than nothing. What I have to pass into it. Or I could call it path to VREP lines like this. I'll do that. That seems reasonable. So I have to give it a path. It works on one path only, which is fine. And it'll basically be this function here, or this setup here. So what I can do is map v apply vrep line, onto partition to one conj vec path first path. So all that is I'm taking the first point and tacking it on the end so that every line that's generated will it closes, right? Because this is a polygon, not a polyline. So a polyline will do exactly the same thing. I'm just wondering if it's smart to do it this way, because I could reuse the function in the polyline thing, except that it would always add a point. So I could take away the logic of adding the first point onto the end of the list and put that in the call when I use this, which might make more sense. So let's do that instead. So here, instead of closing the list, closing the path here. Oh, excuse me. Feeling sneezy, I guess. Okay, so I just map vrep line onto the partition of the path, whatever that path may be. And I can make another little helper function that just closes the path, close path, and whoop, and that just takes a path. And all I have to do here is the conj. Apply vec, right? Or maybe it's just vec, I don't remember. I think this will work. Vec conj vec points path. No, I won't need the outer vec here because they will be forced to be vectors here already. I think this will work. I think. We'll find out. First path. Let's see that actually makes sense here. If I take close path, let's make a path that has 3 points on it. 0, 0, 0, 0, 100, 0, 100, 0, 1, 0, like that. Should be okay. Okay, that works. Okay, good. So all that did is just kind of for the logic of how I'm building out the lines to produce the full polygon edge. It's literally, it just copies this and pastes it on the end of the vector there and turns it into a vector. So let's see if I do it as a list just to be safe here. This is where I will need to spec this stuff out more carefully because there are for sure times where I'm relying on, or I'm assuming that it'll be a vector coming into something, but that's not necessarily guaranteed to be true if you're just using Clojure's built-in list stuff, right? It could easily, like if you conj I did it wrong. Let's get out of here. Maybe a better example is, let's say, take 10 from an infinite range, right? It's not a vector by default. If you reverse it, it's also not, but it still has to realize the whole list, and then you have to do vec that, and anyway, there are situations where it might not be in the right form, and being consistent is important, so have to think about it. But using these two functions here, I should pretty easily be able to do curves now, which will be map v path to, wait, it's got to be a comp which first, what's the application order? Path to brep lines and close path. I think that's correct. So map that composed function onto each path, so onto paths like that. Okay, is this function gonna work? Let's give it a test. Nope. Oh, gotta do that, eval it first. Okay, polygon 2. Let's do, let's run polygon 2 on regular polygon points, radius of 10 pentagon. Something went wrong there. Okay, wrong number of arguments passed to concat new. So I would have to do apply concat new. It looks as if it has worked. So let's have a quick peek here. The history, it appends the polygon call with the arguments passed in as I expect. Pass frep for now because I have to work on that. Vertices is a single list of points. That makes sense. There's 10 points in here because it's 2 pentagons that got passed in. So that makes sense. And curves is a list of lists of curves. Is that what I need? I don't think that's what I expect anywhere else. So that is a deviation. So if I do, let's call polygon on this just to see. It won't work, of course. Oh, I have to go comment this one out. Okay, curves is a list of curves. If I now extrude that, oh, this is messy. If I extrude that shape to a height of 10, okay, so it does generate surfaces now, but it also generates curves, and it's a flat list. There's no nesting of list there. So this, to follow that same logic, this here should be a map cat. So let's try this. It looks good. Oh, except it has to be vec. That whole thing, so it's a vector. Let's try it. Okay, that looks correct to me. Vertices and curves are flat lists, and the history contains the call that had 2 separate lists. Will this actually work is the next thought on my mind. I do believe, at least for the wireframe rendering that I have set up, I do believe it should be fine. So let me, just to mentally confirm that I'm on the right track, let's extrude this polygon to 10. Okay, so it generates a volume, it generates surfaces, which I'm noticing are it's just a flat list here. Maybe it's fine if it's, I don't know. This is working. The vertices are also working. They're extruded properly. That's good. frep, this is going to be wrong for right now because it's got a nil baked into it, of course, which is no good. And the history here has the call polygon and then extrude. Yeah. So this is why I think the history actually, I don't need it to be a like an appending list, because every call into a shape is going to have all of its prior calls built in, right? There's no real issue with that. There's no real need for me to stage it all. You can kind of just assume that prior history, like you just traverse the tree. Do I know what I'm talking about? Not entirely. But I feel as if this history thing needs some needs a small bit of rethinking. That's all. But I'll get there. I'll work on that a little later. Okay, so it does seem to be working. Now the next thing to just test out is actually if I do let's do this. Okay, so I've got this extrude here. Let's do an extrude 10 with just a normal, wrong number of arguments, pass to concat new. Yes. Okay, so one small problem to concat new there. How do I do this without like needing to? I could always cheat a little bit. I could conj. Concat new only takes 2 arguments. So this is actually a problem. Let me just do this. Because concat can take any, right? X, Y, and Z's, yeah. This will just be one empty list, yeah, okay. So let's just do this, vec concat. Oh, you can also run concat on nothing, right? Or on a single list, yeah. For now, this will be easier. Concat new clearly needs a bit of work. And we just do concat, oops. Geez, going wild over here with these. Let's see. You run vec on concat. On apply concat to paths, and that'll produce. Oh, again, I might not need. Since I think vec is fine with. I think this will work. Okay, so let's try this now. Oops. Yes. Okay. So this, what I just did here is ran an extrude on the polygon where I'm only passing it a single list of points instead of 2. So it's effectively achieving the same result as my original polygon function. I'm gonna get rid of this too for now, clean that up a little bit. Okay. Right, so that looks pretty good. Let's see if I can use that now to create something useful here. I'm just thinking how I want to test this in a kind of lazy way. But before, let's not even think down that line yet. What I do want to do is go over here and finish writing this surface call here. So surfaces, here I have an interesting situation a little bit because I haven't really tackled surfaces all that well yet. I just kind of have cheated. Surfaces are another complication, and the reason for that is because of you can have a single path that causes a single surface with no hole, a single surface with a hole, and multiple surfaces. So if all the edges of a single path are, let's say, out here and here, that's just 2 surfaces. If it's a circle inside of a bigger circle, it's 2 paths, or pardon me, it's 2 surfaces where one is the difference of the other. then there's the simple case where it's just a singular path and you don't have to do anything to it. Let's name that polygon old now so that no, actually, until I have good implementations, let's not jump the gun on this one. So the lazy first thing to do is this. I can do, on a per path basis, I could map v, brep, surface, polygon over paths. And what that does is it makes surfaces. But what it does not do is any logic for subtracting if it's one inside the other. And I do need that. So for when I can actually render surfaces properly, which is another thing I have to do. There's a lot of work to do. That is okay. This will work, naively speaking, so that's better than nothing. And I mean, for the sake of having something that might work here too, what I'm gonna do is frep is map v. Wait, no, that's no, that one still needs a bit of work. Right, okay. I don't love it. Let's go save this anyway. We have an initial start. Let's now, I do want to try build out a little test here for a minute. Let's go to design AJTV. Let's open this up and have a look at over here. I have a whole mess of junk. But what I want to do is try to build here. This string here is the path for the letter B. What I can do is create this here, this 2 points thing. I actually need to okay, let's build this out just a little differently here. Let's go def bd points is going to be this is just to generate a test SVG so I can see that things actually do render in a way that I'm expecting with the changes I've made to the polygon function. So we'll see if I can get it to work in just a minute. I'm just trying to think through what I have to do here. So I do know that the BD string needs to be split . Oh, I have to launch a REPL for this, don't I? Let's do that first. Let's go next, cider jack in. We can close that one later, but for now, this will work just fine. All right, let's open up here. Let's load file, source, AJTV, what do I call it, main. Should load okay, I hope. No hiccup? Huh. Class not found. Well, that's weird, but okay. Let's work on that. Hiccup.page. Oh, is it possible that I've done a typo? It's always possible. It's very likely, in fact. Let's just do this. Oops, maybe I should actually read line 14. Okay, that means it's up here. Hiccup.page/HTML5. Does that not exist? What happened? I thought it did. It does. Okay, class not found. What did where did this come from then? I have just confused myself a little bit, that's all. If I go, maybe I have to hiccup.page. Now if I do it, will it work? Let's find out. There we go. I don't know how that happened, but that's fine. Okay, so hiccup.page as page should just let me do this, and that's a little easier. Oop, close that. A bit of a flaw in my org mode setup here, causing it to try evaluate certain things. If I click on a double square bracket thing, it tries to run it somehow, which is a little bit of a pain. But I'll worry about that later. There's so many things that just I could change or should fix, and it gets a little overwhelming, so I try not to think about all of that at the same time because it's also just not helpful. Okay, so we've got the main AJTV thing here and Forge up there. So let's swap this around now. Let's do, so these two at the bottom. Oh, I kind of did this wrong-ish. But this is temporary, it doesn't matter. Okay, all right. Here's a situation that or a situation here. Let's see. I just need to export something to try. That's all I need. Okay. Here, BD points takes split path BD. It takes that. Now I've got a list of paths, I think. And that's the wrong split path BD. That's 2. Oh yeah, okay, so here I have to do map V. For each of those I have to do the this function, turn it into points. So now those are 2-point lists, and then I can use that. I can actually just run it through f/polygon2, which is this that I'm working on right now. and that should let me produce the rest of this. So let's try tacking this onto the end of this, or on the beginning of it, I mean. So I can actually do, I should theoretically be able to do this. Split path, VD, split path. Let's see if that does something. No? What am I missing here? Execution error. Ah, yes, I forgot. I do need to go with another one of these and map v add z to each of those. Right, that should work. Pretty sure that that would have worked. That's okay. Let's do. I don't think this works with 2D points. I just have to double check it though. 1 0 0 0. It does, but I don't think. Let's do first from the curves of this thing. And let's run that with 0.4. Oh, it actually does work. Wow. Okay, not what I was totally expecting, but that's actually fine. It is unsafe because not everything works with only 2D points, so that's not it's not very reliable. Right. So this is wrong. Something's not right here. Let's not chain it all together because it gets a little confusing. So let's do this just as is. Oh, even this isn't good. Really? What's going on with this? Oh, let's not do the polygon thing here. Let's just do this. Okay, so BD points. Right, that's 2 lists of points. Yes, good. So here, map v add z, is that a, yeah. I don't think that's right. I think it's not nested properly, but we'll find out in just a moment. There's an extra. Let's just see the value of this for a second. 83. Oh, wait, what? Oh, it turns out it doesn't matter. This into points function is actually already, there's already an add z here. I'm confusing myself here. That is redundant. So actually this theoretically should already work. The reason it doesn't, I'm not sure yet. Maybe it's apply. Have to do this now. Apply. Right? Yeah. Oh. Hey, okay, there we go. We're onto something. Let's now go SVG. We'll do output slash test.svg. Gotta put it in quotes. Output slash test. Boy, oh boy. Excuse me. Okay, let's have a look at that. Here. Okay. It's a little bit helpful. Let's see here. If I just extrude it by a single point and do the same thing here, refresh this. Okay, that is exciting. This is now the correct rendering of a single polygon that has two paths in it. This is very exciting for me because it's actually a new set of functionality, and I've proved that it works in the case of the edges. It will not yet work entirely with the surfaces approach here because I have to now figure out how to do surface differences, which is something I will do. I will have to start on that. That's going to be tough. I will also fill up my coffee again. So once again, okay. What's a good thing to do next? That's the question on my mind. That is what is on my mind. Well, okay, let's see now if I can resurrect a little bit of This is just for fun, not that. Wrong mouse. There, okay. This is exactly enough improvement to the library for me to progress on my idea for the animation stuff I want to do, which is really exciting. It might mean I can actually get that chugging along nicely tonight, but there's still work to be done. I just had something I wanted to test here. What happens if I do have a circle, right? Circle. Let's do a circle. Let's try this. Instead of this and this and this and this, what happens if I do circle with a radius of 85 and save that? What does this look like? A low low fidelity circle, but a circle nonetheless. Now here we immediately, there's still a lot of room for me to conceptualize a sort of sketch abstract. This circle object is two-dimensional and is completely valid in a generic sense to have as part of a polygon shape, right? But I'm just confusing myself, that's all. I think let's ignore the circle thought for now, because that actually is, I think, something I can handle with union and difference when it comes to 2D shapes. Something I want to attempt no, let's not attempt that. Okay, let's just close off some of these buffers so I can get a little closer to, oops, well, let's save the changes here. Let's bring this back to this. Let's save these changes just to be safe. Okay, now we can close that, close that, close that. Okay, we're back in the Forge namespace, thinking about surfaces and frep. One of the things I will need to do is fix and finalize unions and difference, because I do not have a difference operator for any boundary things, which I need, and it's going to be complicated because I need to handle all kinds of things like intersections and like bounding box checks and whatnot, I think, unless I'm just not understanding things appropriately. So these unions here, these boundary rep union functions, are relatively straightforward. Basically, the curve union just merges the parametric intervals together. So if you have one curve that's from 0 to 1 and another that's from 0 to 1, this curve union just assumes that they're continuous with each other. So it's very brute force, I guess you could say. It's almost unnecessary. In fact, it might not be necessary, strictly speaking. But the brep surface union function works in what way? Oh yeah, the same way. It just like staples two parametric surfaces edge to edge along the u axis, and then recalibrates the u to be from 0 to 1. So if I have two parametric surfaces, it theoretically goes from u0 all the way to u2, and v0 to v1, but then I just smush it along the v-axis. So this is not robust, to put it simply. So I think this is a point of research that I have to start doing a little more carefully here. So let me write this down for myself. Surface union, surface difference, which for certain cases is achievable, I think. Let's do, if I go Boolean operations 2D polygon, there's probably something that exists here that would be a helpful starting point, although I'm not entirely sure. Boolean operations on polygons. This is, so in the 2D case here, right, these are the kinds of things I do need. So two shapes A and B. A not B is difference, that's what I'm referring to. B not A is the same operation, but if you switch B and A around, so I'm not really going to worry about that. Union, A union B, I need for sure. And then intersection and exclusive OR, you can derive from, if you do A not B union with B not A, you get the exclusive OR. Then if you do the exclusive OR not the union, like that, you can use, if you've got union and difference, you can derive the other ones, is the long and short of that. So that's all I really need to focus on for the time being. But I am not currently smart enough to do it. So here, general polygon clipper, right, is kind of maybe what I need to be looking at. I don't know. Software library. Wow. So there is a Java port of general polygon clipping. So maybe that's a path forward. The thing I don't love about that idea is the thing I don't love about that idea is that it's a Java library. I want to build this up with as few dependencies as possible to maintain maximum platform independence. So like, for sure, I want everything I'm writing to work both in Clojure and with minimal reader conditionals, also work in the browser, Clojure script environment, or Node or whatever, because that lets me run it on things like phones and whatnot, which is what I am hoping for. So that's a little bit of a non-starter. I don't really need an implementation. I need details on what the algorithm is, and then I can work on implementing it myself, theoretically, anyway. I'm not sure this is exactly helpful for me. So one thought that comes to mind, well, first of all, if I assume that any starting a lot of sentences and then stopping them because I'm really trying to think through what I actually have to achieve here. It's not exactly easy for me. This is a little bit of a hard thing. So I'm wondering if it's a good idea to make a sort of structure that is a sketch, and sketches are in the XY plane and two-dimensional, but otherwise use the same approach. So they have a functional rep, they have a boundary rep, and they've got the Boolean operations and the transformations. Sketches can be extruded and revolved into 3D. So this has been kind of already what I've been doing implicitly, but I'm wondering if it makes sense to explicitly kind of group 2D related stuff into their own sort of container as a sketch. Does that make sense? Kind of. What if I trap that stuff all into a sketch sort of thing? I can treat sketches as if they were 3D objects themselves, right? So I kind of need I don't know if that is sensible. What I could I kind of don't need to, because I can produce functions that create 2D versions of things, but just produce a map that is just an object like any other thing, 2D or 3D. I can manipulate it the same way. So I could just have sketches be sort of these implicit things, right? And you can def sketch A as some set of lines, right? It can just be, right, a sketch A could, sketches could just be lists of things entirely, and then all you do is union it. You union all the 2D shapes together. Like, might make sense. Kind of makes sense. So here, let me add to my notes here. Primitive functions, this, yeah, here. Thoughts related to sketches might be useful as a grouping mechanism for all 2D things. Could just have all 2D related operations implicitly work on XY plane, and you can use all 3D operations normally. You can you can def a list of 2D things and just map or just reduce them with union. This is typo there. You could just reduce that list with a union to create an object that you can then extrude, revolve, display, whatever. So for now, there is no explicit structure for sketches. They are just user convention at most. I think that's okay for now. That'll have to be, I'm sure I'll have to reconsider this at some point in the future, but I want to kind of approach this with the simplest ideas possible at first. So that is reasonable, I think. Right, so union of two paths. Let's make let's go here. We'll do let's go with this here. Let's just try to organize things a little bit here and label them up. Naive vrep, and now here we're gonna attempt to work on some ideas around VREP. So let's consider first a union of two polygons known to be on the same plane. Assume in XY plane. We need to find all intersection points between polygons. Remove all points from P1 that are inside P2, right? Remove all points from P2 that are inside original P1. Then remaining points are concatenated, but order must be preserved around the new shape. Right, so you can't, you have to insert the remaining P2. Oh boy, this is going to be a little bit tough. Methinks. This kind of makes sense though, I think. You could similarly kind of create if you have actually, so I should say before this, so far, I'm just thinking where I have to kind of branch on different conditions, right? If there's literally a single intersection point, kind of nothing happens because the intersection point has to remain in both cases. But I want to treat those as two separate surfaces. If there's no intersection, they're two separate surfaces. If there is there can be an exact overlap, which is kind of a degenerate sort of thing. That's going to be tricky because of floating point errors and things like that. I won't worry about that for now. If I also assume that the user has to respect the order, right? Like, no, that doesn't, for union it doesn't make sense. It shouldn't matter which one's bigger or smaller. That's also true of difference, so I don't want the order to matter in those cases, so that's fine. Or that'll have to be fine. Okay, let's do 2D polygon intersection algorithm. Let's see if there's something that I can use as a starting point for this. Intersection of convex polygons algorithm. Yeah, so this is pretty much what I do want to find. See here, 2 convex polygons. I will probably have to get more complex again, because I will have concave polygons too. So there's so many things to focus on. It's hard to find a specific order, you know. But I will persevere. There's no reason not to keep trying. Well, okay, let's start with let's make a function that can find an intersection of 2 points. In fact, I might already have that. Maybe not. I do believe I've got in offset prototype. Here we go. We have a line intersection function. Huh. Okay. It causes divide by 0 issues. That is not a good thing, of course. I don't like that. But let's use it as a basis. We'll start. No such namespace G. Let's just pop that like this. No symbol det. I probably have. Let's check out math here. Geometry, determinant 2D. Okay. Keep missing little things here. Okay. Let's have a little think about this for a second. I'm going to draw myself just a test shape. We're going to have line 1 go from 0, 0 to 1, 1. Nice and easy. And we're going to have the second line go from 0, 1 to 1, 0. So that should give us an intersection point of 0.5, 0.5. So that's the little test here, line intersection, intersectione of so there's this function expects. Okay, point A, point B, and this line has CD, like that. Is that correct? I think so. Oh, no. I've nested it one too many times. Yeah, takes 2 lines. That's the arguments it takes. Okay, perfect. So 0, 0, 1, 1, 1, 0, 0, 1. Half, half. Okay, that's good. Is it good that it's returning it as a rational like that? I'm not sure. But until I need to force it to be a float, I'm just going to let it be. Because it looks nice. There's no real reason other than that. I do have a, this is a total tangent. If there's anyone watching right now, by the way, and what I'm saying is very confusing and doesn't make sense, feel free to ask questions. I can try to explain what I'm thinking, what I'm trying to do, all that kind of stuff. But the tangent I just want to go on for a minute is I do wonder if I should come up with a kind of like a whiteboard overlay, so that like I'm drawing on a piece of paper, which is fine. It's all blown out, you can't see it anyway, right? I'm just drawing little diagrams here, but it would be cool if I could just have my iPad as like a permanent overlay, and I could just doodle on that, and then my stream can actually see the diagrams that I'm doing. I think I might do that. So I'm just going to leave a little note for myself there. That seems cool to me. But that is a total tangent. Okay, what am I working on now? Yes, okay, so I have I do need to see if what this will do with terminated lines, right? Because I want a situation like this. Let's do let's do 0, 5, 5, 4. And then this line will be 6, 0, 9, 15. Okay, so these are not touching each other, but this line intersection might provide an intersection point because it assumes that the lines extend infinitely. So that, I think, is not good because it means any check on polygons can yield, it will yield intersection points kind of all over the place. So I do need to kind of clamp it to, do they intersect within the region bounded by the starting and ending points? Is that what I need? Let's check the notes of this for a minute and see if that's anything useful. Bit risky, maybe, clicking a link I'm not sure of. Probably have to be careful with that sometimes, but that's okay. Okay, C code, the method. I should maybe, so I don't want to like necessarily, let's go here, forge model. I am gonna separate out a little, yeah, let's do this. Splines, that's another thing. Okay, 2D algorithms. 2D algos. Perfect. Okay, triangulation currently is 2D. Math geom is a necessary kind of helper, so we leave that up there. Offset proto is absolutely a 2D algorithm, but what I'm going to do is split it here and do offset proto like this, and here I'm going to do Polygon intersection. This is a fine starting point to call it like that. That makes reasonable sense to me. I do need, do I have the 2D bounding box in here already? Bounding box center 2D. I should change how this works a little bit. I should just make a define bounding box. Bounding box. Bounding volume. Oh man, I'm not sure what the right idea is here. If I do bounding box corners of some shape, let's try. Okay, so I have bounding box corners. The reason I'm thinking about needing a bounding box is related to if I have a union, I need to bound both of those polygons so I know the limits of things to test. I don't need to go beyond the size of the bounding box and do tests in space beyond that. So I'm just making sure I have the right pieces to work with. But if I do bounding box corners of a 2D thing, will that break? I can't tell. It will produce. Well, let's not get ahead of ourselves here. Let's just make my own shape here. Bounding box corners. Vertices are going to be equal regular polygon points 5, 6. Okay. It does work. Except for the fact that yeah, those are 3D points already. Okay, let's just take it as something that will work. We'll assume it'll work. And if I do the centroid of that, let me just check that one out for a minute actually. Centroid points. see if that's going to be useful for me. Okay, that mostly works. 0, basically 0, and 0. Map nearly 0.0. Oh, wait a second. Let's do it this way. Partial nearly 0 over this. True, false, true. That's no good. Nearly true, false, true. Let's do an epsilon of that. Let's do an epsilon of a bigger number. My nearly implementation is probably broken because floating points are not something I understand well enough yet, so I need to really work on that. Let's go the other way because it's wrong, obviously. Yep, okay, so this doesn't work, so that's going to be a problem for comparison related things, but let's assume I've got some things to work with. So if I go polygon intersections here, I have line intersection, it exists nicely for me. If I do line intersection works, except it uses infinitely long lines. Here, just gotta move around a little bit. What was that function that I used earlier to find the bounding box? Bounding dash box dash corners. Works with 3D points, but set z equals 0 for 2D. I don't need the word but in there, that's a waste there. And I also have centroid used with above function to get the center point of a shape. Is that true? Center point of a bounding box, not necessarily that shape's mass center. But that's fine for now, it doesn't really matter. Right, the mass center of a thing, shoot, what's that called? I should rechange, I think the mass center of a 2D object has no mass, it's just got area, right? I think it's actually called a centroid, and I shouldn't use the word centroid here. I should use midpoint, really, I think is what it should actually be. So let's change that. Where was it? It was here. Midpoint And that then becomes useful beyond. I don't think I actually use centroid anywhere, so it's theoretically fine for now. So if I use midpoint, it should work between any 2 points at all, right? It doesn't have to just be for corners. It can just be like this. Yeah. Does it work for like longer lists? I forget. Oh, it does. Except, okay, so let's make this a 0, 0, 0, 1, 0, 0, 0, 1, 0, third, 0. That makes sense. Okay, that seems to work okay. But it works nicely for just finding the middle point of a line as well. That'll be useful. Okay. Okay, this might be interesting as an approach here. So this can contain holes, provided that you separate the components and holes with a 0, 0 vertex. Repeating its first vertex after the last vertex. Okay, so you make a closed loop. Then include another 0, 0. Include another component or hole repeating its first vertex. That's kind of an interesting approach. I don't know if that's what I want, because I don't really need it to be that way. I can just make a list of lists instead, but that's a neat idea to use 0, 0 kind of as like a marker for new paths. Okay, well, I clearly need to study this up. This is not going to happen in the last 10 minutes of my stream, so I might call it a little earlier today. But let's have a quick peek here. Flat polygon embedded in a plane in 3D. Project the polygon's vertices, test point into 2D. Do the projection by deleting one coordinate. That's smart, actually. Testing point inclusion in a polyhedron. I'm wondering if that'll be something to do for another day, but I'm wondering if there's kind of a clever way to do that where you project it onto X, then onto Y, then onto each plane, the top plane, front plane, and right plane. And in the projected case, you just check, you make a convex hull of the projected points, check for inclusion in the 2D case, and then do that 1, 2, 3 times, and you need to AND the result. So if it's true in all 3, then it does intersect. That would work, I think, but that's something for another day. But then I need to figure out how to actually do this. Might be important for me as well. Okay, so I am basically going to call it a day, because the next set of things I have to do are going to be a lot of reading and trying to understand things on my end. So I won't be doing that on stream. I will actually, in a completely unrelated thing, I am going to show one little fun thing I managed to pull off before I go. So let me let me. This is not complete by any stretch, but let's see what I can do anyway. This will just be kind of a fun showcase tangent before I go, because what I really need to work on is a lot of research related stuff, reading, that sort of thing. Very boring on stream. Also not great for me either, because my focus needs to be different, so I won't worry about that. So let me close that off. Let me go here and load file. Source humbug main.clj. Should hopefully work. Okay. And I think the sound of this won't be too bad, but so I made a little wave synthesizer sort of thing, and it works pretty well. Let's just do not the Iwato scale, let's do major pentatonic, and let's also make sure I'm using a wave that's not gonna be unpleasant at all. Durations, random song. WF is the waveform, so that's good. Let me create. Okay, so things are loaded. Let me load the namespace here. Now all I have to do is play. I think did I make a play function? I'm not sure. I'm pretty sure I did. Here we go, play. Is main the right? Yeah, it is. Main's right here. Okay, play. What? I thought I loaded. Load file. Humbug / main.clj. No. Why? Well, that's just not helpful. Oh, I have no tangle here. Well, let me fix that for a minute. Tangle. Not sure how that happened, but oh well. Let's go here, paste that. Wave builder, notes, paste that, and paste this. Alright, let's try load it again. Now, wait, really? Seriously? Still not? What's happening? What is going on? Okay, tangled a bunch. Let's see if this looks correct. It mostly does. Let's go here and load that again. Okay, there we go. Now we've got things loading. That's what I need. And now I can play at a sample rate of 48,000 into output.bin. The wave that is generated from a random song using a sine wave I'm only going to take 100 notes. Okay. Hopefully this works okay. I don't want it to be too loud. There we go, nice abrupt ending, but that was a fun little weekend project I did. It was inspired by a video I watched by a YouTube user here, making music with Haskell from scratch. User T Soding. So it was not a fully original idea. I wrote it in Clojure, but the concept of how it was achieved, I followed similar footsteps with this video on the weekend. It was a fun project, and I have some ideas for extending it. But I'm just pretty proud of actually making it work. The hardest thing was I/O related things. So here, I've never used it before, but there's a library called Gloss, written by Zach Tellman. He wrote a lot of, I think, pretty influential Clojure libraries, so Gloss is a pretty well-written library, and it's related to reading and writing I/O for like all kinds of binary related things. I don't know. All I do know is that I needed to find a way to load and save bin files that had little endian 32-bit float encoding, because that is how you can encode a sound wave. And play here is it runs a shell command that uses ffplay. It comes with ffmpeg, and you give it instructions for how to interpret the file at the sample rate. The settings here: volume of, like, the global volume of the wave, sample rate 48,000 samples per second. I do believe 44100 is like what CDs would store audio at or something like that, but it doesn't matter all that much. Pitch standard this is an A4 note in hertz here. Yeah. Let me oops, that's not what I want. Anyway, pitch standard and BPM, can change it up. No, let me 90s, whatever, and 120 BPM, you know, normal stuff. The wave builder here, probably want to improve this abstraction, but it takes a function and then returns a function that produces, that given a hertz and a duration will produce basically a note with that particular wave for that particular note for that particular time. And then there's a few sine waves here that I was messing around with. So there's square wave and half square wave. And I don't know if these are actually like legitimate synthesizers, but they make kind of cool noises. Notes takes a semitone number and converts it into hertz. And I'm using this based on the pitch standard at the moment, so it's like a scale centered around A4. You could, I might change that up a little bit to maybe closer match like MIDI or something like that. I don't know. And then a song is just notes. Oh, the note function, by the way, takes the semitone number, the beats, so it can be 2 beats, quarter beat, anything like that, and the wave function, and then it will produce a wave. And a song is just a concatenation of notes. And what I did here, what I played, is actually a random song that samples just from the major pentatonic scale, so C, D, E, G, A notes, and samples from different note durations with different sort of probabilities. And then I just played it. So yeah, that was just a fun little side project I did on the weekend. It's a lot of fun, and there's a lot of potential here to actually make it more robust, make the abstractions more user-friendly, add things like the ability to change the envelope that you use on the notes, so you have more, say, you can change the attack and the decay, as well as the shoot, what's it called at the end? There's attack, there's decay, and then you've got the release as well. So attack, decay, release, building kind of more complicated functions to make different sine waves, adding waves and notes so that you can play chords, changing the voice of things over time. There's all kinds of crazy stuff you can start to do, and I want to maybe hack around with that over time a little bit. But yeah, a complete diversion from all the 3D modeling stuff, but it was a lot of fun to mess around with and learn a little bit about how to generate frequencies and all that stuff. So yeah, just fun little brag about a project. Yeah, it was great. So that's it for me for the day, though. So if anyone's tuning in at any point, thanks so much. I always appreciate that. And have a good day. That's all I got to say.